Hello. In this lesson, I want you to solve polynomial and rational inequalities. We'll start here by a polynomial inequality is one of the vocabulary words. We're going to discover something called a Sine Chart and rational inequality. A polynomial inequality is any polynomial. Instead of an equal sign, you have an inequality. So you don't do much different on that one. When I solve a polynomial, we'd like to have it equal to 0, or in this case, greater than 0. So what I'm going to do is I'm going to add 3 to both sides. And then I'm going to say x squared minus 6x minus 30, or try that again, minus 27, because negative 30 plus 3 is negative 27. That's going to be greater than 0. Okay, you can write zeros less than if you want to. Now we'll factor that. So I'm going to get x minus 9 times x plus 3. So my zeros are when x equals 9 or when x equals negative 3. Now we're going to put this in what's called a Sine Chart. A Sine Chart is just our number line broken down. So I'm going to put negative 3 on my number line and positive 9 on my number line. Now, in a Sine Chart, each part is either true or false. So it's either going to go false, true, false, or it'll go true, false, true. The adjacent parts are always going to be the opposite. So now how do I figure out which one I'm going to use? Well, I pick a test point. My test point I like is 0. I like to use 0 because 0 is easy to work with. So 0 is going to be my middle section, isn't it? So I'm going to pick as a test point 0. Now let's see if I put in 0. I put in 0 for x, so I get 0 minus 0, so I get negative 30 is greater than negative 3. Is negative 30 greater than negative 3? No, that's not true. So that section is false. So in other words, my graph is going to look like this. My middle section is false, so my other sections are true. So my answer, x can be anything from negative infinity to negative 3, and from 9 to positive infinity. I'm going to use parentheses because it's greater than. It's not just, you're not including it. Now I can check this with my graph. Might be easier to actually graph it. So if I look at the graph, notice on my graph here that when you are at negative 3 and to the left, you're going to be above 0. When I'm at 9 and to the right, I'm going to be above 0. So that's pretty much what we do. Now let's try another polynomial. Let's take a look at example 2. Now we're going to compare it to what we did yesterday. I notice in example 2, I've got this cubic polynomial, so I'm going to have 3 roots, so I'm going to have 3 sections in my Sine Chart, or actually 4 sections in my Sine Chart. I'll first think I'll graph this to use my rational root theorem to try to bring it down to something that's manageable. So if I go ahead and graph this, which I have, okay, here's my graph, and let's zoom in a little bit so I can look at my zeros. One of my zeros is at 3, so let's put in 3 in for synthetic division. So we're going to get 3. Then I'll go 3x cubed minus 4x squared, negative 13x minus 6. Whoops, I don't know why I did that. Draw my line. I should get a 0 here. So bring down the 3. 3 times 3 is 9. 9 minus 4 is 5. 5 times 3 is 15. 15 minus 13 is 2. And then I get 2 times 3 is 6. Oh, look how nice that works out. So now I've got this quadratic. 3x squared plus 5x plus 2. So now equals 0, although it's in inequality. I treat the zeros like it's an equation. So then I can factor that, so I'll get 3x, and let me see here, and x, and I'll go plus 2 and plus 1. Does that work? Let me see. So I'm going to get, no, that does not work. Oh, yeah, it does work. 3x and 2x gives me 5x. So in other words, my zeros are at negative 2/3 and negative 1. So now I make my sign chart. So I'm going to have my furthest number to the left is negative 1. I'll have negative 2/3 and I'll have positive 3. I'm going to pick a test point. I'm going to pick 0. 0 is between negative 2/3 and 3. So that's the part I'm going to check. So I put in 0, 0, 0. Is negative 6 less than 0? Yes, it is. So this is true. So if this is true, that means I'm going to the left as false, false, and true. So my answer for x is going to be from, now notice I've got a line underneath my inequality, so I want to include negative 1. Negative 1 is part of my solution, so I'm going to go from negative infinity to negative 1, and from negative 2/3 to 3. There is my solution. And there we have it.